Hello students, welcome to the course on Hydrology EVE 301 offered to civil engineering students during 5th semester. I am Kirtan Adhikari, faculty at CST. So today let's start with the new unit, that is stream gauging. So basically we are trying to study the various methods to calculate the volumetric flow rate of a stream. So let's go ahead and let's see what's there. So as I have already explained you, we are going to study basically the volumetric flow rate of the stream water. So let's now think about from where this water is coming. So in our previous classes we have seen that as there is a precipitation over a catchment, some of the precipitation evaporates back to the atmosphere, and majority of this precipitation simply runs off over the surface and it enters a stream, and that stream flows downstream. And it is also interesting to note that although we have studied many components of a hydrological cycle, but this natural and we have also studied about the measurement techniques of various components, but only the catchment response or the stream is what we can measure fairly accurately compared to other processes like evapotranspiration or evaporation or even the precipitation. Of course, we can measure precipitation at a particular location, but we know that precipitation varies according to the topography. So exactly quantifying how much precipitation has occurred, that is going to be difficult. But how much runoff is there at that particular gauging site, that we can calculate, that we can estimate, in fact. So here I have given you the example of how the overland flows finally enters into gullies gets into the stream, and stream becomes a river, and then river joins a bigger river, finally it lands in ocean, and like such the entire process of hydrologic cycle continues, right? And like I said here, it is that part of hydrological cycle that can be measured fairly accurately compared to other processes. So that is what I have mentioned here. And the branch of hydrology that deals with measurement of water is known as hydrometry. Okay, so hydrometry is a branch of hydrology which deals with primarily to quantify the water. It discusses all the techniques, methodologies, and various ways to quantify water or measure flowing water. So let's go into the various classification of stream flow measurement. Okay, there are broadly two types. One is direct method, and under the direct method there is area velocity method. We have to compute the area of cross section, we also have to compute the velocity, and then we use the continuity equation, that is Q is equal to AV concept, to calculate the velocity, and that is what is known as the area velocity method. There is dilution method, there is electromagnetic method, there is ultrasonic method. This ultrasonic method uses the ultrasonic sound frequencies to do the discharge estimation. Okay, so as a case study I'll be presenting you a project that was undertaken by final year students of College of Science and Technology, and it was a successful project. There we have used the ultrasonic sensors to do the stage measurement, and finally that stage was converted to discharge. That is going to come next when I discuss about the case studies. And dilution and electromagnetic techniques, these are the techniques which are not very commonly used in Bhutan, so we will not be discussing this. Okay, the other type of classification are the indirect method. So indirect method, we have already seen this in hydraulic courses like fluid mechanics and hydraulics, that the structures like weir and notches are available to do the discharge estimation. And there's another technique, that is slope area method. It uses the Bernoulli's equation to estimate discharge. For this you need flood markings of the region. If you ever happen to be in a site where there has been a flood in the past, so what you can do is, to estimate the discharge, you have to do the measurement of flood level, and then you use the energy principle, that is the Bernoulli's principle, to compute or estimate discharge. Okay, and there are other honorary mentions here which is commonly seen across the country to do the discharge measurement. And some of these techniques, I believe you must have learned about this in your primary classes. And this particular technique, volume by time method, we have used this in fluid mechanics and hydraulics lab, right? So we simply take a bucket here and then we let the water fill up, and we note the time, and volume by time, it gives us meter cube per second, and that is what it is, discharge, right? So this is one way. If the stream is fairly small, okay, like a spring water, then you can use this technique to measure the discharge. There's another technique which we also have studied. This is in the course on open channel hydraulics, that we have used this open channel uniform flow formula, commonly known as Manning's formula, so to estimate the discharge. Here this is in foot pound second system. Okay, so area is measured in feet square and hydraulic radius in feet. Okay, so if you have this measurement, you can use this formula. If you have an SI unit, then the formula is Q is equal to 1 by n a r raised to power 2 by 3 s root of s, where s is the slope, right? Slope is the, how do we calculate slope? So if we have the run and the rise, the tan theta is what you call by the slope. Tan theta is opposite by adjacent, rise over run. So this is how we calculate the slope. Okay, then with this, let's go to new slide, and here we are going to discuss about the discharge or the flow measurement. As I've already mentioned, the volumetric flow rate is what we call by the discharge, right? How much volume of water is passing through particular cross section. Let's say this is a river, okay, and this is a particular cross section where you're interested to measure the discharge. So here there will be some cross section and water will be flowing here. Yes, so how much volume of water, that is meter cube of water, is flowing per second is what we call by discharge. So pretty straightforward, and it is usually measured in meter cube per second. And as an example, I have given you here the Lung Tin Phu. Okay, it's Wangchu, the gauging site at gauging site of Wangchu at Lung Tin Phu, and the average discharge of that river is 22.7. so 22 cubic meter of water is flowing per second. It's a huge, okay, this is a lot of water there. And how do we do this measurement? Now we have discussed the direct method, we have also discussed about the indirect method, and we have also mentioned about other methods like volume and time method and the Manning's equation. Well, Manning's equation, it demands the flow to be uniform, which is not the case always, so let's discard that for now. And the volume time method, whereby you will be recording volume, this is only possible for a very small stream. If you are talking about a river, then it is not possible, because you cannot store that much of water in some bucket, right? So it's impossible to do that method. So we usually use direct or indirect methods. So in this chapter we'll be focusing on area of velocity method. Okay, and to do the discharge measurement at the particular site, it is a time consuming and very expensive process. Okay, because you have to go there, do survey, find the area, and do so many other stuff to calculate the discharge. And you also need to calculate the velocity at different point, then average these velocities, right? And this is going to be very expensive. So if we want discharge data at a very small frequency, for instance 5 minutes, 10 minutes, that is going to site and conducting or calculating, estimating discharge would take half a day. So it's kind of an expensive business too, expensive plus time consuming business, and moreover we may not even get discharge at that frequency. So what they do is they usually, it is two step strategies adopted. What we do is, number one, we measure the stage. Okay, we, instead of measuring the discharge directly, we first measure the depth of flow at different time, and this can be done fairly easily, right? Somebody with the gauge here can easily read what is the level of water. Next is, we develop a chart known as rating curve. Rating curve relates stage or the depth. For now I'm just using the term depth, and sometimes I may use stage is the one and the same thing. Okay, so the discharge is a function of this depth. So what we do is we plot stage versus discharge curve, and by knowing the stage at different time we can compute the discharge. So this process is generally followed across the globe. Most of the river we still follow this method to compute the discharge. Okay, and let's define this term stage and depth. So let me put it here. So this is a river cross section and this is the water surface level. Now if I am measuring this depth from a portion in the bathymetry, the deepest portion, I call it depth, but it will have some water surface elevation, right? Some elevation above the mean sea level. So what is the elevation of this? We call it, if we, instead of mentioning this in terms of depth, if we record in terms of mean, this is mean sea level, the depth above mean sea level as the water surface elevation of particular section, then we call it at stage. Okay, so that's the difference between depth and stage. Depth is it is measured from the bathymetry or the deepest portion of the river, whereas stage is usually, it is measured above the mean sea level. And now let's discuss about how we are going to measure the stage. There are various ways. Okay, now most common way is, you must have even seen this measuring water level staff when you are going some, when you are traveling across a bridge. Usually in the abutment you must have noticed there is a scale there. So main function of that scale is to for the hydromet people to record the stage of the river. So this one is the manual gauging, whereby they will simply install a gauge here, and at the various frequency one person will come and record its level. And what happens is, if this water rises way beyond its reach, another gauge staff is installed at the higher elevation. So then whatever the elevation water is, then we can record here on the another one. So this is known as the sectional way of doing things. Okay, so sectional way of putting a gauge staff gauge to gauge the river. So it's a manual process, so one person has to be employed to take the reading at a regular frequency. And there are other automatic stage recorders like this one, as as this one seen in the image. So what they do is they construct a well whereby there is water is being channeled to the well, and because of the pressure what the water surface elevation at this point will remain same, right? Because the pressure is same. So what they use some kind of float mechanism, and this float will move up and down depending upon the water level. So as water rises in the river, this water rises, right? Because so it will have the same level. So this float will rise here, and accordingly it is recorded here, and that information is sent to the data center. So this is the automatic way of recording stage. Okay, now how we accomplish discharge is, how we estimate discharge is, like I said, we need few parameters to be able to use area velocity method. Like I said, Q is equal to AV. So we need basically two things, area and velocity. For area, there are many ways. One way is go to the field and do the surveying, and that is what is known as wading. Okay, so this, you take a staff and you walk across the river. If the river is fairly small, you can walk across. If the river is large, then you have to have some kind of mechanism that can, that is like a cable way, so you can get into the cable way and then do the measurement. Okay, and there are other like line and cable, that is what I was explaining, and there are other equipments like fathometers and echo sounders. These echo sounders are usually mounted on a boat, and this boat travels across the river, and as it moves it records the bathymetry. Bathymetry means this surface, okay, this bottom of the river is what we call by bathymetry. So then we can calculate the area. Next one is the velocity. So how much velocity is there, what is the velocity of the river there? So there are few methods commonly used when you have nothing. You can use the float method. You must have already done it in your primary classes. You simply drop an object into the river and notice how long it takes to travel a certain distance. So distance by time gives you the velocity, and current meter are the equipments that gives the velocity. Okay, is used to measure the velocity in the river. And this radar gun are the non-contact techniques to measure the river velocity. Just like a policeman standing near a road, somebody is driving very speed, somebody is speeding way beyond the limit, he simply shoots with his gun, right, radar gun, and he calculates the velocity of that vehicle later on to penalize that person. Same mechanism is there. So this radar gun is pointed at the river surface, and then it gives us the direct surface velocity measurement. So, and once we have the area and we have the velocity, next one is, there are two ways to do the multiplication. Okay, one is the mean section method, and another one is the mid section method. Of course we can do directly. Q is called AV, but our cross section varies, and also the velocity at different portion varies, right? So we cannot directly apply A. Of course we apply ultimately Q is called AV, but we need to do it separately at a different strips. Okay, this method is applied at a different strip, so that's why we need, how we are going to divide our stream into various section is given by two methods. So we can divide it by mean section method or by mid section method. So let's, okay, so these are some of the images from this was my project. Okay, so you can see me and my friend Karma standing in the river so we are actually surveying the bathymetry of the Bursa river. So we wanted to calculate the discharge, and so we were surveying this. You can see Leki sir is also along with us. So these are my group friends. Okay, so this and this are almost, we are doing the one and the same thing here. So this, what we call is wading. Okay, so he has tie a rope there so that he can follow this rope, right? Because usually the cross section has to be 90 perpendicular to the flow. So what is holding in his hand is the measuring device, the current meter. So the current meter's wire is here, and this person is, okay, so this person is holding the monitor or the logger, whatever you call it. So here the velocity will appear. So there this guy is recording the velocity at different location of the river. So that's what we call by wading. Okay. And if the river is fairly large, right, like the Sunkos or Manas, Thimchu, right, during summer, is of course you cannot go into the river. So what we do is cableway arrangement, line and cable arrangement is made, and from here we use some kind of equipment to do the depth measurement. Okay, so that is how it is done with line and cableway. In fact, this is somewhere near to if we are going towards Tirang, and you can see this arrangement in Punachanchu, okay, somewhere near close to Wangdi Zong. Okay, now we come to a very important part, that is stream velocity measurement. Now, like I said, there is a before we go into the measurement of velocity, let's understand the profile of velocity. So in a natural stream, the velocity is not constant throughout, as you can see from this image, right? The velocity at it is said that velocity is highest at some 0.2 d, that is the highest velocity, and as you go towards the bottom the velocity decreases and at the 0.2 depth there is a maximum velocity, and as you go to the surface the velocity again decreases. So it has a logarithmic type of profile, as you can. Okay, so that is what I was explaining here. So you can see this. So at the 0.2 depth, okay, if this is the complete depth, at 0.2 d the velocity at this region is highest, and the velocity goes on decreasing. And what we're interested is this average velocity indicated by this dotted line. So usually velocity at 0.6 d is considered the average velocity, okay, because you can see from here the velocity profile, right? And if you now there's a way to measure the velocities. Either you can measure the velocity at 0.2 d and 0.8 d, or that is known as two-point method, or you can directly measure at 0.6 d. So these are the different ways to measure. When I say measure at 0.2 d, what I mean is you have to dip your instrument or the current meter at this height and do the velocity measurement. Okay, you further dip the current meter at this depth and then do the velocity measurement. That's how it is done. So what I have written here, so velocity is greatest on the water surface and part. So simply I was explaining that current meter used to measure the velocity. Yes, so let me show you. Okay, so like I explained you, in a shallow stream up to 3 meters the velocity is usually measured at 0.6 d. So the average velocity here is velocity at 0.6 d. Okay, that is the average velocity. In moderately deep stream, the velocity is measured at 2 points, 0.6 d and 0.8 d. So our average velocity, okay, the average velocity of the stream is equal to velocity at 0.2 d plus velocity at 0.8 d divided by 2. We are simply averaging this. Okay, so this is for deep water. Now during a flood, if you need to calculate the velocity, then the average velocity during high flows or during flood, how we calculate is we simply calculate the surface velocity, okay, the surface multiplied by a coefficient k. Now this coefficient k has to be calibrated when the flow is during the low flow, okay, during the low flow. This value is calibrated during the low flow and it is used during the high flow. So once again, the different ways of measuring velocities. If the river is bit shallow, then we simply measure the velocity at this location. For a fairly deep water, then we do 2-point measurements. For 2-point measurements, first we measure at 0.2d, and again we measure at 0.8d, right? And then we average it out. Now if you have the luxury of time, you can do the 3-point measurements, okay? Like, and to do the 3-point, the average velocity for 3, if you have the data for 0.2d, if you have the data for 0.8d, and as well as if you have the data of 0.6d, then if you can use this formula to find the average velocity. In fact, this is the average of average velocity. How this equation is derived is, first you do the 0.2d plus 0.8 velocity as 0.8d. You find this value plus velocity at 0.6d, okay? Then you again average this. So this is the average velocity of a stream. So if you do the manipulation, you will finally get this equation. It is, first you are averaging this two, then you are averaging with this one, the 0.6d. So that's how you are calculating this 3-point method, okay? 3-point ways of 3-point method of measuring average velocity. So as I was talking about the current meter, right? So this equipment that I'm holding right now is what you call by current meter. See here, this instrument is current meter, okay? This is just the fish weight. Fish weight means if the flow is, the velocity is high, then when you dip your current meter, it will be washed away by the river current, right? So to stabilize it, to keep it at the same location, this weight is used. That's why I was holding, it was 10 kilogram, I think. This was 10 kilogram. It's pretty heavy. If the velocity is high in the river, then you have to use 25 or even more fish weight, okay, to stabilize this current meter. So as you can see in this image, you simply have to put your current meter into the water, and along this wire, this is a wire, and along with the wire there is a cable, and this cable is attached with it is measure, okay? Marking is there. So what is the depth that you have inserted your current meter, you can notice from note from the cable attached there. And there are types of current meters, okay? And yes, this is connected to a logger, and this logger directly gives you velocity, okay? Now modern days, it will directly give you the velocity. In the olden days, it used to give us the revolution, okay? Then revolution, number of revolution per minute. So how much revolution there's kind of a turbine, there is a cup attached to a axle. That cups tends to rotate about an axle here, okay? So the revolution is given in by the logger. Now modern days, directly velocity can be read. So, and if there is, in the olden days, as I said, only the revolution was given. So to convert this revolution into velocity, normally an equation of the form velocity is equal to a plus bn was given, and where n is the revolution, a and b were the constant. So you have to do the manual calculation of velocities, okay? And like I explained, there are types of current meter. This is the propeller type, okay? Usually very small, and the size is very small. And this one is the cup type. Normally for a larger river, this cup type is employed. For a small stream, propeller type is used. It has both the advantages as well as the disadvantage. It can be on vertical axis, like you can see it is in a vertical axis, or it can be in horizontal axis. So if it is rotating like this, then it has vertical axis. Then if it is rotating like this, right, there is the flow, then it has the horizontal axis. So it can be a vertical axis, or you can have a horizontal axis. So like I said, the different types of current meter have its own advantages and disadvantages. Usually the propeller type is employed in a small stream, and the cup type is employed in a larger stream. And most important point to be noticed is it is not affected by the oblique flow, and it is affected by the oblique flow, which means if you are taking this instrument and doing the velocity measurement, you have to be very careful about its orientation, because if you are keeping your current meter oblique to the flow, then it tends to affect. But for current meter, that is not the case. Okay, and usually both are employed in river measurement. And this is one way of measuring velocity, and usually that is the most precise, that is adopted universally. But if you don't have anything to do the velocity measurement, then still you can go for this float method. In this method, 2 person is required. So person 1 stays at some upstream side, person 2 stays at some downstream side, and then you fill a plastic bottle, half fill it with the water, and then just toss it into the river. So as this bottle reaches the top line, then this person is going to say start. So he's going to start noting the time, and as this bottle reaches this line, then he will stop the watch, and the time is noticed, and this distance has to be measured. So you do 3-4 times such exercise, and then you can average out the values to get the average velocity of the flow. Okay, and like I was explaining, so I was holding the radar gun. This is a non-contact measure technique. So you simply put the instrument in your hand and point it towards the flow, and then it will directly give you the measurement, like this one. So with this, I would like to end the first lecture, and we shall continue on this with the next topic, that is the mid section method and the mean section method. Okay, thank you.